Hello everyone, this is Professor Pawan, and in this video I'm going to teach you how to solve this particular SFD and BMD problem. So the problem is as shown in figure. It basically is a simply supported beam with various loads as you're seeing here. First, let me name the salient points here. A, this, let it be B, let this be C, and let this be D. So we can see that there is one UVL, there is a point load, and there is a UDL as well. Okay. So in simply supported beams, before actually going on to draw the SFD and BMD, the first thing that we need to do is find out the support reactions. And here the support reactions will be at 2 points. One is A, I'll denote it as RA, and one at B, I'll denote it as R suffix B. Now, first, let me find the support reaction. So I'll write finding support reactions. So first, what we will do here is we will consider the equilibrium of forces, that is forces, summation of forces acting down or upwards is equal to summation of forces acting downwards. Now, what are all the forces that are acting upwards here? Upward, there are two forces. One is RA and one is RB. So I'll write RA plus R suffix B is equal to, what are the forces that are acting downwards? There's one UVL, there's one point load, and there's one UDL. So I'll first convert this UVL into a load, that is half into 30 into 3 plus this point load, which is 80, plus the UDL, which is having the magnitude of 10 into 2. That is this magnitude into this distance. Okay. Okay. So RA plus R suffix B will be equal to 145 kilonewton. It will be equal to 145 kilonewton. So afterwards, what I'll do, this I'll consider as equation number 1. Let this be equation number 1. Now I'll consider the second equilibrium, that is equilibrium of moments. I'll write considering equilibrium of moments. I can write summation of moment about A is equal to 0. One among the two supports, that is at point A or at support A, the summation of all the moments due to all the forces or all the moments to the right side of A will be equal to 0. So in other words, I need to write down the summation of all the moments about A now. So what will it be? It means that first I'll start considering from right end to left end. So what can I write? RB into the distance is 6 meter. RB into 6 minus 10 into 2 into 5 minus, now I'll consider the UVL, that is half into 30 into 3 into, and this becomes 2. Okay. So what is the equation now? the RB, I'll get it, or simply I'll get it as 85 kilonewton if I solve this, and this is equal to 0 actually. And RA, if I substitute the value of RB from this into this equation, I'll get the value of RA as 60 kilonewton. Okay, I get the value of RA as 60 kilonewton. So this is how I found out the support reactions, one at this point, other at this point. Okay, now we'll start finding the shear forces and bending moments at the salient points. So first I'll write down drawing SFD, drawing SFD. So first I'll, as usual, I'll go from point D to point A. So at point D, what is the SF? I'll write SF at D is equal to, that is equal to this RB, but RB is on the right side and it's acting upwards. So that will be negative. So how much is RB? RB, even though it's 85 kilonewton, here it will be negative, that is minus 85 kilonewton. Okay, then next I'll come to point C. At point C, I'll find out the SF twice, because here we have a combination of UDL, and at the end of UDL we have a point load. So first we need to find out SF at point C due to UDL only, and then again we need to find out SF at point C by considering this point load. So first I'll write SF at C, neglecting point load, and how much that will be? Minus 85 plus 10 into 2. So that, yeah, that makes it 65 minus 65 kilonewton. Okay. Then now I'll find out SF at C, but this time I'll consider the point load, including point load at C. So now how much that will be? Minus 65, which is the earlier value. Now I'm considering this point load, so plus 80. So this becomes plus 15 kilonewton. Okay. Next, after this, this will remain same from point C to point B. It will remain same from point C to point B. And since we have from B to A UVL, this will vary cubically from B to A. So we'll find out the value of SF directly at A. We find out SF at A, and that will be equal to this one, that is minus 85 plus 10 into 2 plus 80 and plus this UVL value, that is half into 3 into 30. So SF at A, I'll get the value, when I calculate, I'll get the value of 60 kilonewton. Okay. So this is for SFD, that is, these are the salient points of shear force values so that we can draw SFD comfortably. So let's start drawing the SFD now. So first what I'll do is I'll draw the datum line. I'll draw the datum line like this. And I'll just mention the salient points on this SFD diagram. Okay. So again, I'll come from point D to point A. So at point D, what's the SFD? SFD is minus 85 kilonewton, and since it's minus, we need to represent it below the datum line. So here is how it will be. Minus 85 kilonewton. Okay. And at point C, it becomes minus 65 kilonewton. And since there's a UDL from C to D, we have a linear variation of SFD like this. And this becomes minus 65 kilonewton. Also at point C, we have one more value, which is 15 kilonewton due to this point load. So I'll make it 15 here, 15 kilonewton. And next, that 15 kilonewton remains same till point B. So I'll draw the straight line from this point to this point. This remains 15 kilonewton here as well. And ultimately, from point B to point A, we will be having a parabolic variation. From B to A, we'll be having a parabolic variation, and the value of shear force at A, it is 60 kilonewton. Let this be 60 kilonewton. And the variation will be parabolic. It will be like this. And this is 60 kilonewton. This is positive. This is negative. And I'm just shading the diagram here. So hence the SFD diagram. Now we'll find out the values of bending moment at salient points and proceed to draw the BMD diagram. So first, I'll write down drawing BMD. Drawing BMD. Again, I'll go from point D to point A. Now, bending moment at D, it is certainly equal to 0. Next, I'll come to point C. Bending moment at C will be equal to, it'll be due to this RB and this 10 kilonewton UDL. So I'll write it down as the value of RB is 85 kilonewton. Okay, so it'll be equal to 85 into 2. 85 into 2 minus 10 into 2 into 1. Okay, so this will be equal to 150 kilonewton meter. This will be equal to 150 kilonewton meter. Next, I'll proceed to point B. Bending moment at B will be equal to, now I'll consider again all the forces which are towards the right side of point B. First, I'll consider RB. RB is 85, so it becomes 85 into the distance. This distance is 3 minus, this becomes 10 into 2 into, this distance again becomes 2. Okay. Minus this one, that is 80 into this distance, which is 1. So bending moment at this point B, it becomes 135 kilonewton meter. 135 kilonewton meter. And then ultimately, if I find bending moment at A, that will be definitely equal to 0. Bending moment at A, that will be definitely equal to 0. So these are my bending moment values. So we'll start drawing the bending moment diagram for this. Again, I'll have to draw one datum line, and let these be the points. I'm taking the salient points here. Okay, now bending moment at D, it is 0. What is bending moment at B? Bending moment at, bending moment at C. At C, it becomes 150 kilonewton meter. So that is this point, and the variation is parabolic. Yeah. So this is parabolic. And yes, in this SFD here, this variation also is parabolic. And this is 150 kilonewton meter. Okay. And then at point B, the bending moment becomes 135. And since there is only point load, this variation will be linear. Like this. This is 135 kilonewton meter at point B. And at point A, it will become 0. But how the variation will be? Variation will be cubic. The difference between parabolic and cubic is that the cubic will be having more slope compared to the parabolic variation. And here it will become 0, and this also is 0. So yeah, this again is the whole thing which is positive, and I'll share the diagram. So this is the bending moment diagram for this particular problem. And yeah, hence these are the bending moment values, these are the SFT values. Okay, thank you people, thank you.